The graph of a quadratic relation takes on a very particular shape. It is a U-shaped curve that we call a parabola. Now, a parabola has some very key specific features, some of which are similar to a linear relation, but there are some differences or features that you don't see on a linear relation or on the graph of a straight line. So in this lesson, we are going to talk about some of the basic properties of quadratic relations. We'll look at how to determine these properties or these values from a graph of a parabola, but we're also going to spend some time focusing on how to actually mathematically calculate some of these properties or some of these features. Because in reality, you won't always be given a graph to work with. And so if you're not given a graph, but you are given an equation of a parabola or of a quadratic, you should be able to calculate each of these values separately. So we'll begin by giving a brief description of each key feature on a parabola, and we're going to start with x-intercepts. So as you recall, x-intercepts are the points where your parabola crosses or touches the x-axis. Now, what's different with a parabola is that typically a parabola has two x-intercepts, or two places where the graph crosses the x-axis. Normally with a linear relation, we only see one x-intercept. Now, why is there two x-intercepts as opposed to maybe one? Well, remember that when you factor a quadratic relation and then solve for the x values, or solve for your variable, you typically end up with two answers. And those two answers are representative of your x-intercepts. A parabola also has a y-intercept. So y-intercept is where your graph crosses or touches the y-axis. And your parabola will have one particular y-intercept. Now, in terms of specific features that are only found on a parabola, we've got two new ones, something called a vertex and a line of symmetry. So let's start with our vertex. A vertex is found in one of two specific locations on a parabola. So when you have a parabola shaped like this, a U-shaped curve that is opening upwards, the vertex is going to be found at the lowest point on your parabola. You could also think of the vertex as like the halfway point on your parabola. On the other hand, if you have a parabola that opens the opposite way, so it's like it's flipped over and it's opening downwards, well then your vertex is going to be located at the top. It is the highest point on your parabola. Still a halfway point or halfway through your parabola, but located at the top. And finally, our last feature is something that we call a line of symmetry, but most of the time you will actually see it be called the axis of symmetry. And an axis of symmetry is a line that cuts exactly in the middle or down the middle through your parabola. So you can see the line drawn in for you here, and it cuts right down the middle, splitting your parabola into two equal halves. And you should also take note that the line or axis of symmetry also cuts or crosses through your vertex point. So that's how you also know that you are cutting it right down the middle. It should be cutting or going through your vertex point. So what we're going to do now is we're going to take a look at how we can mathematically calculate some of these features, including your x-intercepts, your axis of symmetry, and your vertex. So the x-intercepts have alternative names that are used. It's very rare that we see questions that ask us to find the x-intercepts for a parabola. Instead, what you might see are the words zeros or roots. So these two terms mean the same thing as x-intercepts. So if you see a question or an example that asks you to find the roots or to find the zeros, they're essentially asking you to solve for x or your x-intercepts. So how do we find x-intercepts? Well, we learned this in previous lessons in this unit, but the key thing to do is to factor. And we've learned 4 different methods of factoring. So the first step to finding the roots of a parabola is to factor. Now, if you go through every factoring method and you find that the equation is unfactorable, well then you can still go ahead and find the roots by using the quadratic formula. So in our first example, we are asked to find the roots, or the x-intercepts, of the following parabolas. So these equations that are provided to us need to first be factored. Once we factor them, we can go ahead and solve for x. So let's start with our first equation, x squared minus x minus 12. We always want to check when we start factoring if there are any common factors that can be removed from the equation. And when I look at my three terms, there are no common factors here. Something else that we need to do, which I should do before we keep going, you need to set your equation equal to 0. Remember that if you are finding an x-intercept, your corresponding y value will be 0. All right, so common factoring doesn't work. What other methods could we use? Well, I do notice that I have a trinomial, a three-termed expression, where the a value is 1. So that means that I can try to use the sum and product method. So that means I need to take a look at my c value, which is negative 12, and I need to think of two numbers that are going to multiply to negative 12, but they also need to add together to give me my b value of negative 1. So if I do some mental math, I figured out that the two numbers that would work are negative 4 and positive 3. All right, so since we are using the sum and product method, we can go ahead, make ourselves two brackets, and just take those two magic numbers that we came up with and put them into the brackets. So one bracket is going to be x minus 4, and the other bracket is going to be x plus 3. So now we've fully factored our equation. We now need to go ahead and solve for x. So that means we're going to take each factor, separate them, and we're going to set them equal to 0. This is going to allow us to solve for x, and remember x represents your x-intercepts. So we have one x-intercept at positive 4 and one x-intercept at negative 3. All right, let's try the next one. We've got y equals 6x squared minus 8x. So we're going to start by putting a 0 in the place of y, since our equation has to be equal to 0. Our first step is to check for any common factors. So between 6x squared and 8x, there is indeed a common factor, and it happens to be 2x. So I'm going to make myself a bracket. I'm going to recopy the original equation, and each term in my equation is going to get divided out by my common factor. So that's going to leave me with 3x minus 4. So my final factored answer is 2x multiplied by 3x minus 4. So now we're ready to go ahead and solve for x. So again, you're going to take each factor, separate them, and set equal to 0. So for one of our factors, if we isolate for x, we will get a value of 0. And for our other factor, if we isolate for x, we will get a value of 4 over 3. Keep your answers in fractional form. So you've got x-intercepts for this particular parabola located at x equals 0 and x equals 4 over 3. We're now going to move on to working with the axis of symmetry. And the axis of symmetry is really easy to identify when you are given a graph or a picture to work with. So in this next example, we are asked to find the axis of symmetry for the following parabolas. So let's start with the graph for question 2a. And so we have a parabola, and to put in the axis of symmetry, we just want to draw in a line that will cut the parabola exactly in half. So I'm going to go ahead and draw in that line. So you can see the blue line that I've drawn on top of my graph, and that cuts my parabola exactly in half. So now we just need to identify where does our axis of symmetry line cross or touch the x-axis. So remember, your x-axis runs horizontally. So if I follow my blue line, I can see that it is touching my x-axis at a value of 1. So when we report our answer, we are asked to report it as an equation of the axis of symmetry. And so to write it as an equation, you're going to say x equals 1. We use the letter x because the symmetry line is crossing or touching the x-axis. So we're going to do the same thing with the graph provided to us in question B. We need to draw in our line of symmetry. So I'm going to go ahead and draw in my line. All right, so you can see the blue line that I've drawn on my graph, and it cuts my parabola exactly in half. So again, you want to take a look and see where your axis of symmetry is crossing or touching the x-axis, and for this particular parabola it is crossing at a value of x equals -5. So when we express our equation for our axis of symmetry, we are going to write x equals -5. So now what if you weren't given a picture or a graph to work with, but you were still asked to calculate or determine the equation for your axis of symmetry? There's got to be a way that we could mathematically or algebraically determine our answer. And there is a way, and it involves using the x-intercepts. So I'm going back to graph A, and I'm going to just mark in my two x-intercepts. So I have an x-intercept located at -2, and another one located at +4. So your axis of symmetry is actually the halfway point between your two x-intercepts. And so in order to figure out the location of your axis of symmetry, you could simply just take your two x-intercepts, the values of the intercepts, and average them out. And that would give you the exact location for your axis of symmetry. So how do we find the average for two values? You're going to add them together and then divide by 2. So to show my work, I'm going to write x equals -2 plus 4. So I'm adding together my two x-intercepts, and I'm dividing by 2 because there are two values that we are averaging together. So -2 plus 4 is 2. 2 divided by 2 is 1. So you can clearly see that we get the exact same answer as we did when we read the symmetry line off of the graph. We're going to do the exact same thing for question B. So if we take a look at this graph and we do the same thing, we're going to mark in our two x-intercepts. This time we have an x-intercept at -7 and another one at -3. So we are going to average them out. So -7 plus -3 divided by 2. So -7 plus -3 is -10. -10 divided by 2 is -5. So if you aren't given a graph, but you do have information about your x-intercepts, you can go ahead and calculate the equation of the axis of symmetry. All right, the last feature we're going to talk about is the vertex of a parabola. Now remember, the vertex of a parabola is the point on your graph that is either going to be the lowest point on your parabola or the highest point on your parabola, depending on which way your graph is opening or the direction of opening. Now again, we like to use alternative names for things in mathematics. So sometimes what you will see is the term optimal value. Remember that optimal value refers to the y-coordinate of the vertex. So not the entire coordinate point, but specifically just the y value. So let's say I have a vertex and it's located at 3 and 4. and you are asked to identify or state the optimal value. Well, the optimal value is just the y value of your vertex. So remember, in a coordinate point, the first value is an x value. The second value is a y value. So in this case, if your vertex is at 3, 4, your optimal value would be 4. Now, an alternative name to optimal value that you might see is either maximum or minimum value. Now, to decide or distinguish between which term to use and when, that depends on what your parabola looks like. So let's say you have a regular, normal-looking parabola that is opening upwards. Well, your vertex, remember, would be located down at the lowest point on your parabola. So this is what we call a minimum, which makes sense because a minimum means the lowest or the smallest, and our vertex is indeed the lowest point on a parabola like this. If your parabola opens the opposite way, or it opens downwards, well then your vertex would be located up here at the top, and it would be your highest point on the parabola. So we can use the word maximum to describe this type of vertex. And again, maximum and minimum will only refer to the y value on your vertex. In our next example, we are asked to determine the vertex of each parabola and the maximum or minimum value. So again, when you have a picture to work with, it's very nice and simple and straightforward. So let's start with graph A. The first thing we want to do is identify the coordinate point for our vertex. So our vertex is located right at the top, and that particular coordinate point is located at 1 and 9. Now, is this a maximum or a minimum? Well, because our vertex is located up at the top, it's the highest point on our parabola, we are going to identify this as a maximum. But the way that we're going to officially state our answer is we're going to say there is a maximum or max value at 9. Remember that we are only focusing on the y value of our vertex. So our maximum value is located at 9. We're going to do the same thing with graph B. We're going to identify our vertex, which is down here at the very bottom. And as a coordinate point, that would be -5, -4. So this time, do we have a maximum or a minimum? Well, because our vertex is located down at the bottom of our parabola, it's the lowest value on our parabola, this is going to be a minimum. So we are going to state our answer as minimum value at -4. Again, we're only pinpointing or focusing on the y value of our coordinate point. Before we move on to the next section, I just want to draw your attention to a very specific detail about a parabola, and it has to do with the axis of symmetry and your vertex. So I'm going to go back to graph A, and what I'm going to do is draw in the axis of symmetry very quickly. So I've drawn in my axis of symmetry line in green, as you can see on the screen. So let's just identify the equation for this axis of symmetry. So if I follow my line, I see that it crosses or touches the x-axis at a value of 1. So the equation for this axis of symmetry is x equals 1. So, where have we seen that number before? Well, our symmetry line is at x equals 1. And if we look at the vertex, the x value of our vertex is also 1. So whatever value your axis of symmetry is located at, that is also the x value for your vertex. Remember, your symmetry line has to cross through your vertex point. So they do share that value in common. So if you know the axis of symmetry value, you actually know half of your vertex. And so it's just a matter of then figuring out what the y value will be. And that's what we're going to take a look at next. So as mentioned, you won't always be given the graph of a parabola to pick out all of these key features. However, we can determine the vertex of a parabola from its equation as long as we can find or identify the axis of symmetry. So we're going to go through the steps now of finding the vertex when all you have to work with is the equation. And so here are some of the basic steps that we're going to follow. Step one, you need to find the zeros or the x-intercepts. Remember, these two names represent the same thing and can be used interchangeably. And so the way that we find x-intercepts are we try to factor the equation and then we solve for the x-intercepts. Once we have the x-intercepts, remember that you can average them out in order to find the value for your axis of symmetry. If you have the axis of symmetry, remember, it's the same as the x value of the vertex. So by finding the axis of symmetry, you're actually finding half of your vertex. Once you have the x value of your vertex, you can simply just plug it back into the given equation in order to calculate the corresponding y value. And once you have the y value, you can put it together with your x value and come up with the coordinate point for the vertex. So in our final example, we are asked to find the vertex for the following parabolas, and then we need to provide a sketch for the parabola, or of the parabola. So we have an equation given to us. We need to ask ourselves, do we need to factor this, or has it already been factored for us? And the answer is it's already been factored for you. You can tell because you've got two sets of brackets, okay? And normally factored equations have brackets built in, okay? Remember that if you were to FOIL this, okay, you would regenerate the fully expanded version of this equation. So this is already factored for us. So all we really need to do now is find the x-intercepts. So that's going to be our first step. So in order to find our x-intercepts, I've taken each of the factors that were inside brackets, I've separated them, and I've set them equal to 0. So if we solve or isolate for x, we will have one intercept at 4 and another intercept at 2. Now that we have our x-intercepts, we can go ahead and find the axis of symmetry. So just a side note that sometimes the term axis of symmetry is abbreviated to AOS. So to find the axis of symmetry, I'm going to take my two x-intercepts and average them out. So that means I'm going to add those two numbers together, 4 plus 2, and I'm going to divide by 2. 4 plus 2 is 6. 6 divided by 2 is 3. So my axis of symmetry is x equals 3. Our last step is to take our axis of symmetry value and substitute it back into the original given equation. So I've recopied the original equation. And now what we're going to do is everywhere we see the letter x, we're going to replace it with our axis of symmetry value, which we calculated to be 3. So that's going to give us y equals 2. And then inside one bracket, we'll have 3 minus 4. And inside the second bracket, we'll have 3 minus 2. So 3 minus 4 is negative 1. 3 minus 2 is 1. And if we multiply that together, we will get y equals negative 2. So to now state the value of your vertex, you are going to put together your x value, which comes from the axis of symmetry, and your y value, which you just calculated. So your vertex is going to be located at 3 and negative 2. So in order to make a very rough sketch of your parabola, you are going to put down 3 points. So you are going to plot your two x-intercepts, and you are going to plot your vertex point. So I have an x-intercept at positive 4. I have an x-intercept at positive 2. And I have a vertex point at 3 and negative 2. So if I follow the curve or the curvy shape of those points, that's going to give me a parabola that looks like so. So we get a normal, regular looking U-shaped parabola that passes through those 3 points. Remember to include arrowheads on the ends of your lines. All right, now it's your turn to give it a try. You are going to follow the exact same steps from example A in order to determine the vertex for this parabola. And once you find your vertex, you can go ahead and make a sketch of the parabola. So pause the video, calculate the information needed, make the sketch, and then come back to see the full solution. All right, so if you did the work, you should have found that your vertex is located at a coordinate point of 1 and 4.5. So to go through the steps, we had an equation given to us that was already factored. So all we had to do to find the x-intercepts was take each factor from the brackets, separate them, set them equal to 0, and solve or isolate for x. So we have x-intercepts located at a value of -2 and 4. Once we have the x-intercepts, we can go ahead and calculate the axis of symmetry. And to do that, we just need to average out our x-intercepts. So that means we need to add them together and divide by 2. So -2 plus 4 is +2. 2 divided by 2 is 1. Now that we have our axis of symmetry value, we can take it and plug it back into the original given equation. So that means wherever I see the letter x in the equation, I'm going to put in my axis of symmetry value of 1. So if I do that math and solve for y, I get a value of +4.5. So if I put together my axis of symmetry value and my calculated y value, I get my vertex point. So I've plotted my vertex point and my 2 x-intercepts and joined them together to make a rough sketch of the parabola.